So we have this equation. This is an absolute value. Now we know the absolute value of a quantity is equal to the quantity as long as the quantity inside the absolute value sign is positive. If the quantity inside the absolute value sign is negative, then we have the negative. The absolute value is the negative of that quantity. Let's think about this a minute. Let's first assume that y is positive. And that makes sense. If y is a population, you can't have a negative value for the population. Now, if y is greater than 0, we note that as long as L minus y is also greater than 0, this quantity inside is going to be positive. So that absolute value of y over L minus y just equals y over L minus y, as long as L minus y is greater than 0, or y is less than L. So on the condition that y is positive and y is less than L, we can replace the absolute values, or we can just remove the absolute value sign. Now if we remove the absolute value sign, the equation just becomes y over L minus y equals a e to the KLT, and we can solve the equation for y. Multiply both sides by L minus t, we get L minus y. Y equals L minus y times a e to the KLT. If we distribute, well, let's go ahead and write it out just to be careful. This will be L a e to the KLT minus y times a e to the KLT. Now we got a y term here and a y term here. We're going to add this to both sides and then factor, and we're going to end up on this side with y times the quantity 1 plus a e to the KLT equals L a e to the KLT. We divide both sides by this coefficient of y, and we get our final solution for y, which is just that y equals L a e to the KLT divided by 1 plus a e to the KLT. We note, before we go on to analyze the solution a little further, let's just note that when t gets very big, the AE to the KLT here and the AE to the KLT here will pretty much, well, the AE to the KLT here is going to be pretty much equal to 1 plus AE to the KLT, because the AE to the KLT terms are going to become huge. The 1 isn't going to make much difference, so that we can pretty much neglect the 1 in the limit of large T, and then this will divide into this, leaving us just L, so that this does approach the limiting value L as T approaches infinity. Now remember that L is the limiting value that we've assumed for the growth rate. So we know that this function is going to have this behavior as T gets large.